We have an equation to solve, and then a problem where we're given a profit function, ask what value of x makes the profit equal to whatever your g. So we'll start with the first one. So using fairly arbitrary numbers, I'll say 7 over x minus 9 minus 11 equals x. You need to have just a plain reflex. You kind of maybe need to write out a map of what you do when you see an equation. Okay. And one of the big things on your map, a set of things that you always ask yourself is, does the equation have a denominator? One or more denominators? If so, then you need to multiply by all the denominators, preferably by least common denominator, because it makes everything a little less messy if you use the least common denominator. In this case, you've only got one denominator, so your denominator is there. So we got the denominator, which is x minus 9. So we multiply both sides automatically. Okay, we write this down. We don't do anything with it except write it down. Then we decide what to do with it. Well, if we're used to multiplying through by denominators, which always, in any case I can think of, I'm sure there are exceptions, that they're probably contrived, but 99.9% of the time or more, it makes everything simpler. You don't want to deal with the fractions. Okay, so now what do? We apply the distributive law. The distributive law is very straightforward. You multiply x by 9, x minus 9 by this, and x minus 9 by the minus 11. Okay, there it is. Now, one little thing we'll do here is we'll put a 1 down here so we make sure we understand what's going on here. I've said this a number of times, and I'm not going to take the time or the space to tell you that we can switch the x minus 9 and the 1. Because this product is just a product of the numerator times a product of the denominator. I've said this many times, it's not quite sinking in because it's a little bit more complicated, okay, than you really want it to be. You want to just be able to cross these things out. In this case, you could, but until we know the rules, we're going to think it through. And when you think it through, you're going to say, well, if I switch the x minus 9 and the 1, then my denominator is going to be x minus 9 times 1. Okay? The denominator, as it is here, is 1 times x minus 9. Well, either way, the denominator, if you multiply this out, is going to be x minus 9. Okay? So I could put the x minus 9 under the x minus 9, which makes it clear that the x minus 9 divided by the x minus 9 is divided by, can be divided by the x minus 9 to give you 1. Since that can be done, this whole thing just gives you 7. But there are details of that. And again, I've said it many times, people strongly tend, almost everybody doesn't understand the rules of calculation at this point. and cancellation. So I don't like to use it. Okay. Anyhow, we just completed this. It's really pretty simple. If you want to just write down a 7 here, if you think that, you know, that's going to give you 7, just don't make a mistake because I won't be very forgiving. Okay. And what I mean by that, what you need to do is you need to think that through. You visualize, okay, I can put this over here, I put the 1 over here. Doesn't change the numerator, doesn't change the denominator of the product. And then I've got x minus 9 over x minus 9 and so on, and now everything comes out. 1 times 7 over 1 is 7. Okay, now when I'm in this position, really on this step, as soon as I see this, I understand that I've got a quadratic equation. Okay, so we kind of put a note here. Got a quadratic equation because of its x squared. And then what we know is we need to put the quadratic equation into its general form. And the general form has 0 on one side. Everything has to go on one side except and it leaving us 0. So what we have to do is we're going to subtract the x squared minus 9x. So we do 7 minus 11x plus 99 minus the quantity x squared minus 9x equals x squared minus 9x minus the quantity x squared minus 9x. So this is going to give us 0 because we're subtracting this from this. This is the same thing as this, except we got a minus sign here. So this gives us 0. Now you could do that in 2 steps. You could subtract x squared and add 9x, okay? So another way to write that out would just be minus x squared plus 9x, if you like that better. So I'm actually going to write it that way. But if you understand what I did here, it's worth making it note. Okay. And I'm going to write it over here the same way. So another way of looking at it, instead of subtracting the whole chunk x squared minus 9x, is we subtract x squared, so that x squared goes away, and we add 9x. Exactly the same thing. We do a minus x squared here, we got 1 here, we got a plus 9x, we got a plus 9x. Then it's even more clear that this gives us 0. And what do we have over here? Well, we got a minus x squared. And then what else do we have? We have a minus 11x and a plus 9x. Well, that's a minus 2x. And then we have 7 and 99 is 106. Okay. Now this is standard form. This is ax squared plus bx plus c equals 0. Where a is -1, because what's in front of x? A is what's in front of x squared, it's -1. B is what's in front of x. And c is 106. So x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. That's the quadratic formula. You've got to know it. So that's negative of -2. And this, if you know the quadratic formula and know to put the equation into this form, you're home free because all you got to do is identify A, B, and C, plug them in, and do the arithmetic. Nothing tricky about it. once you get to that point. It's not that hard to get to that point in most cases. Okay, so that's. Yeah, right, that's kind of small, because we did one last time, and you see them in open math. So what you really need to see is this is going to work? And one thing I'll point out is that is -1. Don't do like I do. Make sure you are very careful about getting the right numbers in here. Okay. Because then you know you're at a loss. Okay, well, you do the arithmetic and you get, in this case, I'll write it as it's 2 plus or minus the square root of. That's 4. And this is 424. That's 428. Over -2. Now everybody knows that the square root of 428 is about 20.6. Everybody knows that, right? Well, your calculator does, so it's perfectly permissible to use your calculator. Another thing you can do is you can factor out 4 here, and 428 is 4 times 107. So this would be the square root of 4 times the square root of 107, just 2 times the square root of 107. But I'm not going to take it any further than that. At this point, you can put this into your calculator, and you can get the decimal approximation that staggered many significant figures. So your solutions are -2 plus this, -2 minus this, both over. Sorry, 2 plus the square root of 428, which comes out about 22.6 over 2. And -18.6 over 2, which is like -9.8 over 2. Is about -9.3. So I'm going to say this comes out approximately. About 11.3 or -9.3. And I think I got my signs wrong there because I think that's it. I'll put a question mark in there. The solution is very simple. Okay. Now I'm going to take this just a little further because your homework for next time is going to talk about the graphs of these things. We talked about them last time. I'm going to talk about them a little more. Okay, so okay, we have this. Now I can write this as 2 over -2 plus or minus the square root of 428 over. It's over -2, but I'm just going to put it over 2 because you're going to do a plus and a minus here. Okay. The reverse, I'm going to switch the minus and the plus. If you do plus the square root of 428 over -2, you get minus the square root of 428 over 2. If you do minus the square root of 428 over -2, you get plus the square root of 428 over 2. So x equals -1 minus or plus squared of 428 over 2. And that is approximately -1 minus or plus 20.6 over 2. And you can then get your numbers. If we want to graph this function, well, if we want to graph this, the graph of clearly right over the graph of this has y-intercepts when this equals 0, right? I'm sorry, it has x-intercept and y0. Let's do the y-intercept. Y-intercept when x equals 0. So the y equals -0 squared minus 2 times 0 plus 106. Now this is exactly what you do to get the intercepts in a straight line, right? You just let y equal 0, you get the x-intercept. You let x equal 0, you get the y-intercept. So we're letting x equal 0 to get the y-intercept. Y-intercept is at a point 0, 106. Well, we can draw the graph with it. And so right here, just say that 100 is here, so 50 is here. There's 30, 40, and so forth. Okay, this would be zero, 106. The graph has got to go through this point. The graph of y equals this expression, which is the expression we got out of that equation. So just forget about the equation, we've already solved it. But we're going to use the solution, see what the graph of this function looks like. Okay, well, what are the x-intercepts? The x-intercept happens when y equals 0. And x-intercept, okay? It's going to have more than one x-intercept, unlike a straight line that has just one x-intercept, or maybe none if it's a flat line above or below the x-axis. Y equals 0. Well, y equals 0, we just write this equation. There's the equation we would solve. Well, we already solved it. Okay. X is -1 plus 20.6 over 2, or X equals -1 minus 26 over 2, 20.6 over 2. Okay. Now, I went and drew the graph, and yeah, you could actually see the y-intercept on the graph. I'm going to move the board over here so that anybody who's looking at this online will be able to see this. Okay, so there we have. We have two values when X equals 0. Okay. Now, -1 plus 20.6 over 2 is 22.6 over 2, which is 11.3. And looks like, yeah, I had my signs wrong here. I'm going to keep my question mark there for that, because that's something else. But those are the right signs now. No, wait a minute. I made a mistake, changed the signs, and I thought I made a mistake, so I changed them again. But that was a mistake, so I changed them back. Okay. I guess -1 plus 20.6 over 2. 20.6 over 2 is 10.3. Okay. -1. So let's say that I put -1 here. My line X equals -1. Now, -1 plus 20.6 over 3. Well, we can move to the right. (20.6 over 3 units). That's what we mean by -1 plus 20.6 over 3. And here we are at -1 plus 20.6 over 2. Let me get 3. Not even a 3 on the board. I don't know what I did, but I think I was dividing the 20.6 by 2 to get 10.3. And I had that 3 in my bed. Whatever it was, not right. Okay. So 20.6 over 2 is 10.3. -1 plus 10.3 is positive 9.3. So there's my point. Now, if I go to the left, I'll call that -20.6 over 2, which is -10.3. Now, I have another 0 here, and that's at -1 plus 20.6 over 2 equals minus 20.6 over 2. Do like I do, which is -1 minus 10.3, which is minus 11.3. Okay. But this illustrates, where I got those numbers when I finally got the signs right on them. I think the numbers are probably right if 20.6 is right. And I think 20.6, maybe between 20.6 and 20.7, you do your calculator, see if I'm right. And laugh at me if I'm wrong. I don't mind. Okay, so we have 3 points now on the graph. We can connect these 3 points to a smooth curve, which is going to be a parabola. And the parabola isn't going to peak here. It's going to peak on the line where x equals -1 because the parabola is symmetric. Everything to this side, well, these two zeros are at equal distances from x equals -1 because of the way I wrote this to illustrate that and drew this picture. It should be pretty clear that this is going to be the axis of symmetry. And I believe you're going to see that terminology in open math initially. We have a symmetry about this line, the symmetry being that anything that happens on this side also happens on this side. It's a mirror image. What happens on this side is a mirror image of what happens on this side. And if that's the case, then we simply have to have the peak that was a really bad parabola. Oh, there's my. Okay. Right, it's okay. So the parabola doesn't have a little dip in here. That little dip came about because I was trying to aim at something I couldn't see through my arm. So I'm going to maybe fix that shit. Oh, that's going to be even worse. Okay, that's a little better. Still not very good. Okay, it's a badly drawn parabola. Okay, so this is graph of y equals -x squared minus 20x minus 2x plus 106. Okay. Badly drawn parabola. It has the shape of your basic squaring function. Okay. The y equals x squared function. You do the table and graph the y equals x squared function, you get a nice smooth parabola. Okay. You take that parabola and you stretch it out or compress it or squash it one way or another, but maintain the parabolic shape, turn it upside down, and it fits here. Through any 3 points that have different x coordinates, you can always fit parabola. Transformed square. Okay, go ahead and ponder that for a minute. Okay, so just a quick review. Basic squaring function, y equals x squared. You have a graph. You should be able to draw as quickly as I'm drawing it. Okay, turn it up a little speaker on this side. It's symmetric. Just like this is symmetric. Okay, symmetric. That one's symmetric about the origin, about the y-axis. I mean, sorry, about the y-axis. Okay. This one is symmetric about x equals -1. So this means that the vertex of this graph is going to transform here. What's your transformation? You move it left 1 unit and up, we don't know how many units yet. A little more than 106 units. Okay. So we could estimate that maybe 110. We can easily calculate. Yeah, it's negative. So it's going to be 109. How to get that? Wasn't hard. I plugged x equals -1 into this. Because whatever the y value here is, it's going to correspond to x equals -1. So to get the y value, I put x equals -1 into this thing, and I get 1 here, and I get 2 here, which adds up to 3. And add that to 106, I get 109. I said maybe 110. Okay. That was just a lucky guess. It was just a round number, a little bigger than 106. Looked about right. Okay. So we transform y equals x squared to get y equals -x squared minus 2x plus 126. Okay. The axis of symmetry here is on the y-axis. It's at x equals 0. Everything that happens on this side of x equals 0 is a reflection of everything that happens on this side of x equals 0. It moves to x equals -1, which is halfway between the zeros at -1 plus and minus square root of 428 over 2. Now that's where the zeros are. 10.3 is our approximation of the square root of 428 over 2. And that gave us this picture. Okay. Okay, I'm going to introduce an f of x notation here because I need it now to talk about what I'm going to do to find the y intercept. So instead of saying y equals this, you'll say y equals f of x equals this. Well, y equals f of x. If x is -1, then y equals f of -1. Okay. So go ahead and calculate f of -1. Just like, you know, -1 in for x here and see what you get. Everybody did fine with this. I saw a couple of arithmetic errors there, but you're entitled to that because I did a bonehead thing when I calculated this in my head. Negative x squared is not one. X squared is one. Negative x squared is -1, right? Because it doesn't say square negative x. This says square x and then apply the negative. So we've got to be careful. That's a common error. Okay. Ordinarily, I'd be surprised I made that, but not having that has a real good week of attention here, I guess. So anyhow, y is then negative x squared. That's negative of -1 squared minus 2 times -1 plus 106, which is -1 plus 2 plus 106, which is 107. And my estimate of 110 wasn't really great. Okay, seemed a lot flatter at the top than I drew. I almost kind of trying to develop a little point at the top. Okay, that's a parabola don't do that. But parabola is much smoother near the vertex. Okay, well, what does this tell you about this function? Horizontal shift is -1, right? Because the vertex had to go from here over to -1. Then it's got to go all the way up to 107. Here's our vertex. -1, 107. And then we have I would say a vertical stretch by factor -1. We're multiplying. We've got to get a negative x squared. Okay. Well, that's a -1 times x squared. So that's a reflection. That's the way you saw it when you did the transformation. So then we're going to say a reflection. Through the x-axis. So what we think is we do this first because we always do reflections and compressions and so forth before we do any shifts. Because reflection is a multiplication by -1. We got to multiply x by -1, then we do the shifts. Okay. So multiply x squared by -1. That's our reflection. So multiplications, we do it for horizontal and vertical shifts, which involve additions or subtractions. Horizontal shift. Replace x by x minus h. Okay. H equal to -1. That's our horizontal shift. Then we add 107. That's our vertical shift. What does the function end up? Okay, so I calculated all this. We get y equals a negative of x minus -1 squared plus 107. Okay. Work that out. Let me write it a little more clearly together. Expression. Extra parenthesis in there for you guys being careless. Okay. In other words, we start with x squared. We multiply by -1 to get negative x squared. We replace x by x minus h, which is negative of x minus -1 squared. And then we had 107. Those are our transformations. And this is what's going to be called the vertex form of the parabola, or the quadratic function. Work this out. Expand this, multiply it out, and simplify it and see what you get. Okay. If you simplify this, first of all, x minus -1 is x plus 1. Make sure you got that. I think maybe somebody had a minus there when it's plus. Okay. Now, what's x plus 1 quantity squared? It's not x squared plus 1 squared. There's a distributive law of multiplication over addition. There is no distributive law of exponentiation over addition. So get that out of your head. I remember making that mistake maybe once or twice. Okay. I picked up on it pretty quick. But, that was back when I was young and smart. So when you look at it, it looks like that's what you want to do. We don't do mathematics by what it looks like. We let what it looks like guide us, but we check it out. Okay. X plus 1 squared is this. Now there's a special product, but I don't like to use special products because people don't remember. Okay. So people have to go back to the laws to do things. Eventually you might remember the special products. Okay. And they're worth remembering. But I don't waste time in special products because they don't stick. Okay. Well, how do you multiply this out? Well, you can do the thing with the little loops. Okay. I'm going to put some dots in here. You just can't bring yourself not to use the little loops. Okay, you're better off writing the distributed law the way you see me do it. Okay. When you multiply that out, you get x squared plus 2x plus 1 because x times x is x squared. X times 1, x has to be multiplied by that 1 too, it's x. And then 1 gets multiplied by this x, that gives you 2 x's. And then 1 multiplies 1, you get 1. Okay. Okay, well, that simplifies. Well, go ahead and simplify that. Because I really want you to see how this works out. Because everybody did the right stuff except that step. And maybe the negative of a negative through somebody, but I don't remember. Okay, we want to get to that last problem, so I have to cut this short just a little bit, but everybody either has it or all they got to do is add -1 to 107. And there we have it. Now, where have you seen this before? This is the same as this. Now remember, we started with y equals, so y is going to equal this, y is going to equal this. In other words, this is just another form of this. So if we look at this is what we call the vertex form. And over the next couple of assignments, OpenMath is going to reinforce what I've just told you. Okay. What I've shown here. Okay, well, that's good, but we do have one more problem that we can dispose of rather quickly. There's an important idea here. We want to be sure we have that. Okay, for this second problem, where'd my chalk go? Okay, for the second problem, P of x equals this. Oh, well, okay, so P of x equals, let's say, x minus 3 times x plus 9 plus 12. Okay. So interpreting this, the profit function could be this. And we want to know what x gives, profit 23, right? Well, P of x is the profit. So we solve P of x equals 23. If P of x equals 23, then our profit is 23. Well, P of x equals 23 is just x minus 3. X plus 9 plus 12 equals 23. Okay. Now everybody correctly uses the distributive law when you see this. You got to remember to do that when you have a square also, or cube, or anything like that. This works. Then we get x squared plus 6x minus 27 plus 12 equals 23. Or this which ultimately gives us x squared plus 6x minus 48 equals 0. That skips some steps. You need to fill in those steps. You need to do all the steps so that you keep reinforcing what you need to do. But here we have it. Well, how do we solve this? We apply the quadratic formula. Very straightforward. Around the room, we have 36. 4 times 48 is 192. Then we have a negative, so it's plus 192. And add 36, you get 228. Check my rate. I think I'm not going to double check. Okay. So this is approximately -6 plus or minus 15.1 divided by 2. You get your numbers. The positive number is the one that you want if you assume that x has to be positive. And got a question here, so I probably messed up something. Okay, I was doing this quickly and I got 48, but I should have got 38. That should be 38. That should be 38, which is going to make this 40 less. So this is going to be 188. And square root of 188 is 13, about 13.7 maybe over 2. 13 squares is 169. Okay. Yeah, 14 squared is 196. That's a little close to 196. And then we could write that as -6 over 2 plus or minus 13.7 over 2. Put that in the number line. Reinforcement as before, which is 3. -3. 13.7 over 2. With 6.9. .9 here. Those are our two solutions. This one's positive. -3 plus 6.9 is 3.9. So when x is 3.9, our profit should be pretty close to 23. Now I've got some approximations in there. Did the arithmetic kind of quickly in my head. Made a mistake here, corrected it. I think I corrected it more or less correctly.